Hi everyone, we want to solve this differential equation with power series. The initial problem is y double prime minus y equals to 0 with initial point x0 equal to 0. So we have y equal to sigma and starting equal to 0 goes to infinity, a n x power n. We get a y prime, a starting point n equal to 1 goes to infinity, a n n x power n minus 1. We get a y double prime equal to sigma n equal to 2 goes to infinity, a n n n minus 1 x power n minus 2. We're going to be plug back all this stuff in the actual equation, y double prime minus y equal to 0. So we have a starting point, the y double prime equal to sigma, a starting point n equal to 2 n minus 1 x n minus 2 minus sigma n equal to 0 goes to infinity, a n x power n equal to 0. So to get the n equal to 0, so we have to replace n by n plus 2. So if we do that, we get sigma n equal to a starting point 0 goes to infinity, a n plus 2 n plus 2 n plus 2 minus 1, which is going to be actually n plus 1, multiplied by x power n minus the actual sigma n equal to 0 goes to infinity, a n x power n equal to 0. So if we factor all this out, so what we get? We get a n plus 2 n plus 2 n plus 1 minus a n, all those multiplied by x power n equal to 0. Let's start with the n values. N equal to 0, what we get? We get a 2 multiplied by 0 plus 2 multiplied by 0 plus 1 minus a0 equals to 0. So our a2 equals a0 over 2. The next point is going to be n equal to 1. We have a3 multiplied by 1 plus 2, 1 plus 1 minus a1 equal to 0. So our a3 is equal to a1 over 3 multiplied by 2. So the next point is going to be n equal to 2. So the a4 multiplied by 2 plus 2, 2 plus 1 minus a2 equal to 0. a4 is equal to a2 over 4 by 3. So our a2, if we back into that previous one, the first one, is a0 over 2 over 4 by 3. So we're going to be a0 over 2 by 3 by 4. So the next point is going to be n equal to 3. a5 by 3 plus 2 multiplied by 3 plus 1 minus a3 equal to 0. Our a5 is equal to a3 over 5 by 4, which is our a3 is a1 over 3 by 2 over 5 by 4. So our a5 is going to be equal to a1 over 2 by 3 by 4 by 5. The next point, we have n equal to 4. What we get for a6 equal to a6 multiplied by 4 plus 2, 4 plus 1 minus 4, a4 equal to 0. Our a6 equals to a4 over 6 by 5. So what is our a4 if we back into the previous one? So we have a4 is equal to a0 over 2 by 3 by 4, right? So is all those over 6 by 5. Our a6 equals to a0 over 2, 3, 4 by 5 by 6. So what we get? So then we get our a2k. So you know the definition of 2k is going to be the even number, and 2k plus 1 is the odd numbers. So for our even numbers, we get a2k equals to a0 over 2 by 3 by 4 by 5 all the way up to 2k, which is equals to a0 over 2k factorial. For the odd numbers, we have so a2k plus 1 equals, so the next one is going to be a0, the next one is going to be a1. So we have a1 over 2 by 3 by 4 by 5 until 2k plus 1. Which is,
there is some one thing going. Okay.
So equals to a1 over 2k plus 1 factorial. So our recurrence relation, what going to be? It's going to be a n plus 2 by n plus 2 multiplied by n plus 1 minus a n equal to 0. We're going to be solve it for a n plus 2. What we get? We get a n over n plus 2 multiplied by n plus 1 for our n equals to 0, 1, 2, dot, dot, dot. For the part B, we want to find the first three terms in each of two solutions, y1 and y2. So the formula for our power series solution, we have the formula which is going to be yx equals to sigma n goes to n equals to infinity, 0 goes to infinity. A n x power n equals to a0 plus a1x plus a2x squared plus a3x cubed and so on. So what we get from that, we get a0 plus a1x plus, what is our a2? What our a2 is a0 over 2 multiplied by x squared. What is our a3, which is a1 over 2 by 3 x cubed. And what is our a4 is a0 over 2 by 3 by 4 multiplied by 4, x over 4. So if we factor it, what we get a0 multiplied by 1 plus 1 over 2 factorial x squared plus 1 over 4 factorial x cubed plus dot 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 plus our a1 multiplied by x plus 1 over 3 factorial x cubed plus 1 over 5 factorial x over 5 plus dot dot dot. So what we get? So we can get our y1x equals to the first portion of the previous one, 1 plus 1 plus x cube x squared over, sorry, so we get x squared over 2 factorial plus x power 4 over 4 factorial, and it keep going, and the y2 going to be x plus x power 3 over 3 factorial plus x power 5 over 5 factorial plus dot dot dot. Alright, so if you plug the initial value we have on top, which is our x equal to 0, right? So x0 equal to 0, so we plug it back to the ry's. So for y1, 0, we get 1 plus 0 over 2 factorial plus 0 over 4 factorial all the way. So all those 0 is going to be 0. What we get 1. And for y2, if you plug the 0 in, we get 0 plus 0 over 3 factorial plus 0 over 5 factorial. So our answer is going to be 0. If you get the y prime from these two y's, for y prime 1, 0, we get 0. And for y prime 2, 0, we get 1. And for part C, we want to evaluate the Wronskian to check our y1 and y2 form a fundamental set of solution. So on the formula that we have w, y1 and y2, put it in the matrix, we get y1 0 and y2 1, y prime 1 0, y prime 2 0. The previous one's supposed to be 0.
Nope.
Alright, so what is our y1 0 is 1, and our y2 is 0, and our y prime 1 is 0, and y prime 2 0 is equal to 1. So if we solve that, what we get 1 minus 0 equal to 1, and it's not equal to 0. Because it's not equal to 0, our y1 and y2 are the form a fundamental set of solution. Alright, I hope guys enjoyed the video.